Where have I been? Well, for the last 10 days, I've researched two stories that have completely changed my world. One about consciousness and one about instant faster-than-light communication. And what I found is not what I expected. Hey everybody and welcome back. The first rabbit hole I dived down was because of you. A viewer asked this really smart question about quantum instant communication. They said, Simon, why would quantum instant communication only be used in radio telescopes? Wouldn't it be used in technology? And certainly the military would really benefit from instant quantum communication. Good point. So partially to prove to you and to prove to myself that quantum instant communication actually exists, obviously the military would have an application for it. So where is it? Sadly today, most conflicts that are occurring in the world are a long way from NATO countries. Thousands of miles. So drones or unmanned aerial vehicles are the backbone of the modern Air Force. Gone are the days of humans in planes. Okay, maybe transport aircraft and a few fighters, but the percentage of missions flown by unmanned aerial vehicles, drones, has increased dramatically. So it struck me as a private pilot flying a drone from a Portakabin in Omaha, Nebraska, all the way in Iran, you would have latency. What's latency? Well, we've all come across latency on our Xbox or our Nintendo. When we make the Mario Brothers jump, you press a key and you want Mario or the Tomb Raider to jump. I'm showing my age. But if it doesn't jump, that's latency. And us humans find a great disconnect with a machine that doesn't respond instantly to our press. None more so than a pilot flying a fly-by-wire or a remote UAV. If you go left and it doesn't turn, and in fact that's a real hazard even in non-fly-by-wire planes. There's this effect called pilot-induced oscillation. And what that is, an aircraft, unlike a car that you steer down a mountain road and there's a direct connection between the steering wheel and the tires, and you can hold the lane, you hope, pretty well with steering. In a general aviation airplane or an airliner, when you put in a control, that's a Spitfire. When you put in a control, there is a delay. The control surface then moves, the air then flows over the wing, over the raised or lowered control surface, and the aircraft begins to bank or yaw. I mean, we know that as pilots, but there's a very dangerous mistake that rookie pilots make. They believe that the plane is like their car. They put in a control and they want the plane to move. What actually happens is you put in the control and then 1, 2, 3, the plane slowly begins to react. 1, 2, 3, and it slowly begins to react. So because of that delay, often on landing, the plane is coming down, its nose is going down, you pull up, nothing happens. The plane then goes up, so you pull back and then it goes up and then you push down and then it goes like this and you get into this oscillation. Here's a video of it happening. It can be fatal. And that's all caused by latency from moving the control to something happening. And we are very bad at processing that. But just imagine the latency of flying a drone 1,000, 2,000 miles away. Well, is there a latency? According to the US Air Force, drones fly with zero latency. That doesn't make any sense unless they're using quantum instant tunneling communication, which I don't think they are. So do drones have zero latency? Obviously not. from your control cabin with your joystick flying the drone, the signal still has to, at the speed of light, go probably up to a geostationary or low Earth orbit satellite and then back down to the drone, and then feedback comes the other way. And amazingly, the figure that is mentioned by the FAA is 240 milliseconds. That's quite a long time. The FAA, in conjunction with NASA, have done research with humans flying planes for fly-by-wire or drones, I suspect, and say this figure, 240 milliseconds, is the maximum the human brain can cope with latency. More than that, we tend to put in too much control before the little bugger has reacted. Then you could get into pilot-induced oscillation, which is, dangerous or even fatal. But here's the first strange thing I found down the rabbit hole. So the FAA have said this magic figure of 240 milliseconds. That's exactly the time, FAA, a signal takes to go up to a satellite and back down to a drone. Why did they pick 240 out of their hat? I think it's a bit of a big coincidence, FAA, because 240 is exactly the time that the speed of light or radio waves take to control a drone. But hang on a minute, the US Air Force are claiming zero latency, not 240, zero. And I don't come across any evidence that they're actually using quantum instant communication, which of course would be zero latency. That's not the answer. The answer is absolutely fascinating. It appears to me that latency is very important to drone operations. It can actually be more than the bounce of 240 milliseconds because they put in encryption to stop bad actors controlling the drone. But the drone pilots don't see the latency. Why? I think it's quite complicated, and that latency amount is variable depending on how far the drone is away. The first answer is they don't actually fly the drones. Drones today are often pre-programmed to take off, fly a flight plan, and then land with no human intervention, apart from a surveillance operator who's looking at the camera and a weapons officer that can fire stuff. And a bit of latency, 240 milliseconds or so, is okay. It's just not okay for the pilot with the joystick, but they're not actually flying it. That's the first answer. The second answer of why the Air Force might have zero latency is they aren't flying the real plane. So that's another possible answer that I found. So your Top Gun pilot, your F-16, your F-18, your Navy, Air Force, Army pilots are very rare. The majority of pilots today are actually drone pilots, and they're actually regarded as second best. That's very harsh, and it's not actually coming from me. I think it's coming from the Air Force. I think they regard drone pilots not quite as on a pinnacle as a fighter pilot. And because of that hierarchy, drone pilots, Top Gun, that introduces two very weird, not commonly known aspects of being a drone pilot. The first one is a game changer. They don't actually fly the aircraft even when they're controlling it. They have zero latency because they're flying a game. They're flying a graphical reproduction. They're flying a computer over there, not the drone over there. Effectively, they're flying an Xbox Nintendo drone reproduction. Then the actual drone, the unmanned aerial vehicle, is clever enough with sensors and AI to compensate for the latency from the human with no latency playing a game going woo up to the drone, and it slowly moves and it's not going to crash. But the human has no latency because it's the human that has the problem, not the drone. Remember pilot-induced oscillation. If you can get rid of that by making the drone operator actually fly a game, there's no latency. So they, the human, won't induce pilot-induced oscillation because there is no latency. Now, I'm slightly guessing on all this, and I've asked a number of drone pilots to actually get back to me, and I've heard some really interesting things about how they communicate from the base operations to the drones. The most interesting and little-known fact that certainly I didn't know is that drone operations for the Middle East, say Iran and Israel at present, are happening from Germany, which is within the 1,000 or 1,500 mile range of a Predator or Reaper or other drone types I don't know about. And no doubt during the Afghan conflict there was a friendly country within the 1,000 mile range. They weren't necessarily flying them back from Omaha, Nebraska in Afghanistan. I don't think that makes any sense. There's usually an allied friendly country within the 1,000 mile range of a Raytheon Boeing drone. So I haven't found the most obvious smoking gun military application for quantum tunneling real-time communication. In fact, they trick their pilots, and they also affect their brainwaves to help their concentration. That's not nice. So thank you so much, all my patrons specifically, who've helped me understand latency, PoE, drone flying, satellite communication times, and other latency that's put in to encrypt the drones. You guys know a lot. The whole idea of Patreon for me is really working. You have the inside knowledge, and because you're supporting me, you help research these films. That's worth $3 a month, and it's great for me. Thank you very much. So diving into the quantum instant communication rabbit hole led to another tunnel. An interesting thing about human consciousness. We're at a breakthrough stage where we're beginning to understand what consciousness means, and maybe its actual method of how we feel conscious. And part of that research is by studying how we become unconscious. Read the work of Roger Penrose. Microtubules in our brain, and possibly microtubules in all creatures, and even inanimate objects, might be that interface between the very small quantum and the very big world that we live in, which apparently makes a feeling of connectivity or consciousness that we all have, often linked to a spiritual feeling or even a religious belief. But the quantum world has another strange side effect, and that's temporal or time. I stumbled across this YouTube clip that really was very intriguing. It tied together some research that I've been doing about remote viewing.
Theorists as prominent as Nobel Prize-winning physicist Roger Penrose have hypothesized that the brain is actually a room-temperature quantum system. What does this mean practically? And how does this allow our brains to predict the future? Well, in quantum mechanics, you of course have Einstein's spooky action at a distance, or spatial non-locality. Everybody likes to talk about this. Entangled photon pairs across the world seeming to mirror each other in ways that break Einstein's speed limit of light. But to me, perhaps the even more mind-blowing thing about quantum mechanics is that you don't just have spatial non-locality, you have temporal non-locality, spooky action across time. Say you entangle two photons with each other, photon A and photon B. You then run the classic double slit experiment with photon A. Wait a few days and run another double slit experiment with photon B. If you don't observe either photon in the experiment, you'll get an interference pattern for both photon B and photon A. If you observe photon B in the second double slit experiment, it will collapse into a particle state and go through one of the slits. But here's where things get crazy. It looks like the measurement and collapse of photon B is causing the collapsing of photon A into a particle state too, even though the double slit experiment with photon A is happening before the experiment with photon B. In other words, the two photons are entangled not only across space, but across time. This looks a whole lot like either retrocausality or, dare I say it, time travel.
Now, as you know, I was very honored to host Jat Sarfati, the physicist, here, and I've also spoken to Russell Targ. Both Jat Sarfati and Russell Targ collaborated at SRI, Stanford Research, very much on Russell's remote viewing program, which became Operation Stargate and then got moved over to the CIA. The idea of remote viewing was to ask people in the program if they could think of answers at a remote distance, so I thought, to look behind closed doors underground to reveal secrets, say, during the Cold War about Russian nuclear facilities. That's what I thought originally, but that's not the full story. Remote viewing is also temporal. It sees through time, and what I've discovered today is incredible. I think the best way to describe what I've discovered is to tell you a story, a famous remote viewing story. A Russian spy plane in the 1970s under the Carter regime, while SRI and the CIA was using remote viewing, crashed into Africa, a big continent, and they wanted to find it because on board there would be secret papers or technology that they needed to reproduce and understand how the Russians worked. There was no foot soldier information to know where the plane had crashed in Africa. So the CIA turned to Stanford Research and Stargate to ask if a psychic could find the plane on a map of Africa. And this famous woman psychic looked at a map of Africa and drew a 30-mile circle in Zaire in the Congo. People went there and they found natives taking bits of aluminum back to their houses to build stuff, and they found the crashed wreck of this Tupolev plane. It turns out that the plane was a Soviet aircraft, but in fact it was being flown from a secret base in Libya for the Libyans' operation, looking at probably South Africa. So she found the plane using psychic powers, and it became really famous. Jimmy Carter said this: and there was a big to-do at a press conference, and the woman who'd found it was, "Way, you found the plane, the psychic warrior." And she became very famous. That's not what really happened. She told a very different story, which reveals maybe how distant viewing actually works, by actually looking back from the future. What am I talking about? Well, she explained. What I'm about to tell you now, I'm hopefully going to make clear enough, but you might have to listen to it twice because it's mind-bending. What she said, the woman who found the plane, was she knew that she'd found the plane because she had a premonition of how famous she became in the future, and she could see where the plane was found by her at a press conference that hadn't taken place yet when she was in the past. So she didn't find the plane by thinking about where the plane might be. She found the plane because she was going to find the plane in the future, and she could look into her future, and she remembered from the future that she did find the plane. So she was able to tell the people in her present, before the plane was found, where the plane was, because she saw a map of after she had found it. Do you want me to repeat that? Distant viewing might work because the distant viewers have confirmation that they succeeded in their mission. SRI, Russell, Targ, and the CIA always included the distant viewers in the results of their survey in the past. If they got it right, they were told all the details of what they got right. Why? Well, because in the past, they could project to that moment where they were confirmed that they were right to reveal in the past what they were just told. That's mind-blowing. And very interesting. And I'm not making it up. Here's a report, a piece of paper, Dr. Becky, a peer-reviewed piece of paper, saying that the confirmation of success to remote viewers is the temporal clue to why remote viewing in the past actually works. I had no idea until I started researching these topics for you, the YouTube audience, that drones have zero latencies because the pilots are playing a Nintendo video game and are being tricked to remove the human oscillation from the equation. And remote viewers need to have confirmation that they were correct, because in the past, that's what they can tune into to reveal the secret before it happened. We live in a fascinating world. The truth is out there.